Okay, quick review here first before I start this last topic here. Last unit, when we were in the area unit, we had two similar figures. And I'll tell you, this side is 4 inches, this side is 1 inch. Anybody remember what we called this ratio here of two corresponding sides? It was our similarity ratio. Anybody remember from last unit, if we knew what the ratio of two sides are, what else did we know the ratio of? The area by doing what? Squaring it, yes? And we also knew the what ratio? Anybody remember? Not just the area ratio, but perimeters. How are they related to the similarity? They're the same, so the perimeters would also be 4 to 1. We're going to do the same exact thing today, except talk about the surface area ratio and the volume ratio. If I know this, how do I get to these two? And I'm sure most of you could probably guess, but we'll figure it out in a second. So that's what we're doing today with the three-dimensional objects. If I know the ratio of two sides, how do I get to volume? How do I get to surface area? Okay, so similar solids. How do I know if I put two solids on your desk, how do I know they're similar or not? Well, first thing, and this is almost a common sense thing, is they got to be the same solid. Same solid. Because we are talking 3D objects here, so they got to be the same solid. Can't have a cylinder and a cone be similar. It's not going to happen. Second thing, corresponding measurements have to be in the same ratio. This isn't like we're going to see each other again here. You guys are like thinking like you're just going to walk out the door. Maybe I'll appear at the Regents exam. Good luck. All right, so let's try this out. Let's take a look at number one. I got two prisms, so that's already number one's already checked off the list. They're the same solids. But now I have to just check, are the corresponding measurements in the same ratio? So somebody start me off here. Give me two corresponding measurements so I can put them into a ratio. Why did 100? Let's try this again. All right, let's start off. 7. 4 to 7. All right, you're going small to big. Fine with me. 4 to 7. Is that in the same ratio as? Give me another pair of corresponding sides. 23, you're up. 8 to 14. Now let me just make a quick point here. Hey, awesome if these two are in the same, but all three have to be. All right, you're not a winner because the first two have. All labeled sides have to be in the same ratio, so now we have to check 6 to 10.5. How are you guys checking if those are in the same ratio? Find the decimal value. Find the decimal. When you have two ratios, you can cross multiply. 3 is a little bit different. We'll find the same we'll see if they all equal the same decimal. And what are you finding? 1 point, what is it? I got the other direction, sorry. What's the decimal here? Okay, I'm just going to put 0.57. 0.57. 0.57. Oh, it's over. So yes, they're similar. Not done with the problem, though. What do I need to do if they are similar? Give me the similarity ratio. There's a lot of ratios you could give me here. A lot of ratios. I just want one of them. If they are similar, what's the similarity ratio? Here you go, 4. Similarity ratio, Emma. You could say 4 to 7. You could say 8 to 14, 6 to 10 and a half, 0.57 to 1. It's up to you. All right, up to you. All right, what about the cylinders? Well, they're both cylinders, so that takes care of that part. But are corresponding measurements in the same ratio? 6. Give me a pair of corresponding measurements. 5 to 9. Is that in the same ratio as 9 to 12? Now, because we have 2 of them, you could cross multiply and see if they equal each other. And I don't think 81 is equal to 60. So we're going to say not similar. Perfect. All good. A lot of hype. A lot of hype. That was the wipe, by the way. We discussed last week. That was the wipe. You done? Fresh cut, by the way, huh, Danny? Fresh cut? Professional or homegrown? Do you approve of it? How much say do you get in it? Really? Look at you, boss, huh? Good. All right, good for you. How? Because I feel like it's been a while since you got one. Is that really how long you go in between cuts? A couple months? Well, this is, I don't know. I haven't seen it like that in a while. Okay. All right. What do you ask for when you sit in the chair?
What do you ask for?
What do I ask for? 0 on the back and the sides and a 4 on top. Blend it in. Fade it in. That's what I asked for, if you're wondering. If you want to ever get the Jay Carlino special. All right. There you go. That's what you can get. 0 all around, 4 on top, fade it in. Fade it in. Oh, it's pro. It's pro. Yeah. And nobody from home's touching this. All right. All right, here we go. So now let's turn it to 1 month. 1 month. 1 month. Anything else here we got to answer? Anything else? Even though it's not Wednesday and it's not my interview. Anything else we got to ask? 100%. My mom doesn't come and say, cut it this way. Sorry. She doesn't accompany me at all.
Where do you get it?
Well, long story here. We just moved to Del Mar in this past August. So I used to get my hair cut in Gilderland, where we used to live around. But now it's a little bit of a length, a little bit long drive, and I'm a busy guy, all right. And so I had to find some place in town. So I first went to the Del Mar Barbershop, which is across from the Tools restaurant there. Not a big fan. Went there twice. He didn't really understand the whole blended in. It was literally like the 4 and then a cliff, and then the rest was shaved. And I wasn't a big fan of that because I could have just taken a bowl at home and cut it myself like that. So now we're at Joe's across from the Key Bank. Yep. So I'm pretty satisfied with what he does. So, yep. So that's where I'm going. All right. All right. Trying to transition back. If I do know the ratio of 2 sides of any solids, I can find the surface area. They're not equal to each other. Surface area. Surface area. What do you think I'm going to do to this similarity ratio? Square it. Yep. So I'm going to square the similarity ratio to get to the surface area ratio. And I'm sure you can guess, just based on how we leave the units for any volume problem, what are we going to do with the side ratios? Cube them. Yep. If I want to get to the volume ratio. All good? Okay, here we go. I've given you two cylinders. They're similar to each other. I've given you the two cylinders. They're similar. I've given you the surface area of both. Could you give me the ratio of the heights, the ratio of the radii, whatever, just the ratio of two corresponding parts? I've given you, and it's got to be, please read carefully, it's got to be smaller to the larger. So we know the surface area is 49 to 81. But I want the corresponding sides now. The heights, the radii, the diameters. What should I do here to get to that similarity ratio with the 49 and the 81? 27, any thoughts? Take the square root of both, yep. So the similarity ratio will be 7 to 9. Oh, what about if you know the volumes? What if I know the volumes here? 125 over 512. And I want to get to the heights, the ratio of the lengths, the widths. Suggestions for the volumes, 3. Cube root. And this is, again, we've done this on your calculator. Anybody remember? Pretend I wasn't here that day. How do you go to the cube root? Hit math, yes. Some of you may be able to do alpha window, but everyone can do math, the math key. Left-hand side. Bless you. And the ratio of any corresponding sides would be 5 to 8. All right, we're ready to step it up a little bit now. Let's see if we can help each other out here.
I didn't get the last one. Can you go back?
I'm good. Ask somebody in your group. All right, here's the part now. Two figures are similar. I'm going to give you the surface areas of both of them, the volume of one of them. What's the volume of the other? Well, I can't do this. I'll tell you what, I can't do this. 75 over 108 equals, what's that, 216? That's the volume of the larger one is given. So I can't do this. Because if you try that, here's what you're telling me. The surface areas and the volume ratio is always equal. Absolutely not. Absolutely not. So if you're trying to find the volume of the smaller one, I need your help to get the volume ratio. I need to know what ratio the volumes are in to be able to set up a proportion. So what ratio do you know? Surface area. All right. So I know the surface area is 75 over 180. All right, honors kids, need your help to get to the volume ratio. I didn't give you that conversion on the last page there. I didn't say surface, do this to the surface area to get to the volume, but you have enough knowledge to get from surface area to the volume. How? Think about it. Discuss it if you need to. How do I go from the surface area to the volume ratio? You may need to take a detour first. What can you get from the surface area? The sides, the similarity. How? How can I get to the similarity ratio? Take the square root, so square root of 75 over the square root of 108. Leave that as a fraction, please. I don't want that decimal in your calculator. You should get your math button, change it back to a fraction. What are you finding at it for the side ratio, the similarity ratio? You should get a nice clean fraction back. 20, are you getting a nice clean fraction back? Tough to do without a calculator? Okay, you all right? 5 over 6. That's it. We're good. What's the problem, Roman? You all right back there? Did you get a fresh cut too? No. Okay. Sorry. I'm a little late to that game. All right. Is that what I need, though, for my proportion? Nope. I'm not going to say 5 over 6 equals x over 216 yet. I need to get to the volume ratio, so let's keep chugging. What do you want me to do to the 5 over 6 to get to this volume ratio? 21. 5 over 6. How do I get to the volume? I know that, but it's not equal to 5/6. Cube it. That's what I'm looking for. Yep. Now, can you just set up your proportion with 5 cubed over 6 cubed? Yeah, you could. All right, I'm just going to find the actual 125 over 216. Now that finally we have the volume ratio. So now I could say 125 over 216. Again, you could also have 5 cubed over 6 cubed. That's fine. Equals, which one was I given? The larger or the smaller volume? 216 is the larger. What's the smaller? And this is total coincidence. It's not going to happen on the next problem. I know some of you are thinking that. Volume of the smaller one? 125, 125 units, centimeters cubed. Okay, I'll give you a second, whether it be by yourself or on your own. Go ahead and try number 6 now. Find the volume of the smaller one.
I get it. It's just annoying. And it contradicts everything. It hurts.
All right, here we go. So we can finish it up. Any issues here? 256. This is what you can expect on your test as far as this stuff goes. I'll give you, or what if I change things up and give you both volumes and one surface area? I would start off by taking the cube root and then squaring it instead, okay, to get to that ratio. Any issues from you guys here? Because as you can see from your notes, we are now down to the last problem. This is it right here, the last problem. Yep. All right, what do you want? I'll give you Promethean Man right now, if it is, no homework or what? I'll give it to you right now. What else here? One last vote for the year. One last vote.
It's gonna be curtains. It's gonna be like slide right. Dan, what do you have? Remember you take volume is just the side ratio. That's the volume. You don't cube that.
Anything else here so we can get going? What do we have? Yeah, okay. Yep. Okay, are we done here? Here you go. Curtains. Shatters. Fade. Cube. Cube. 2 cubes. Pinwheels. Genie. Slide. Either way. All right. Curl. Star. Clock. Swings. 1, 2, 3, 4. Anybody swing? 4? 5. Swing, Roman. Drop. Wipes. Flip. Okay, it's down to swing and curtains here. If you don't want to vote, that's fine. Sure, I'll give you both then. Fine. Okay, Promethean man, curtains or swing? And just so we're clear, swing is from the corner. Swinging around, right? Correct, from the corner. Here we go, last one. Anybody have a birthday this month? Who's the earliest? So who has the earliest? Okay. Early birthday present. Come on up. Swing, curtains, or Promethean man? That one right there. Here we go. Ooh, fade. Thank you. Fade. Who had the two? Who are the two fades here? There you go. Should have listened. All right, here we go. Final 2 problems here. We have a block of ice that weighs 2 pounds. We'll even go diagram for you. Last problem. There's your 1 cube, weighs 2 pounds. It's an ice cube. And we're going to draw one where I'm going to increase each dimension by a double. I'm going to double it. What's the weight of this new one here? Get on my level. Okay. Okay, what do we think here? If I'm just going to double, is it just going to be 4 pounds? I'm going to double each dimension, double the weight, right? It's not how this works. Not how this works with weight. All right, with weight, we're talking about volume here. All right, so it's just not as easy as just double it because I'm doubling the dimensions. So let's say this one is, let's just pick 6 inches. What's going to be the other dimension over here? 12, okay. Let's start getting, what's the similarity ratio? 1 to 2. And I know the pounds, in this case, the pounds are the volume of the smaller one, which is 2. Okay, I'd get 4 there, but that's not correct. Because you're telling me the sides and the volume always in the same ratio. I need you to adjust that for me. So it is a correct proportion. What do I need to do to that side ratio here? I need to cube it. So you'll see it's much heavier than just doubling the weight. And the weight of the new one ends up being 16 pounds. Just by doubling each dimension. That's it. That's all I got. That's all I got. Again, clear out your binders when you have time before Thursday. If you have a textbook, start bringing it in tomorrow. Okay, but for now, that's it. We'll review tomorrow.